Hello, everyone. Um, Today, there are 3 different people going, and we each have 15 minutes, and we're already like 5 minutes into it for some technical difficulties, so I'm going to go ahead and get started to make sure that there is time for everyone. I'm really glad that I wrote all notes down to make sure I squeezed it into 15 minutes, so my apologies if I'm somewhat of a reader, but it's the best way to give you as much information as I can in this short amount of time today. I'm Allison McGrath, and I'm an assistant professor at Otterbein University. And today I will share with you my research on students with learning disabilities in middle school science-inclusive classrooms. Science achievement has been a nationwide concern for all students, and the nature of science education and what it means to know science, has changed significantly. The launch of the Next Generation Science Standards in 2013 was brought on to improve student interest in and knowledge of science. The Next Generation Science Standards utilizes an inquiry-based approach to learning that emphasizes the needs for students to act as a scientist through direct experience of scientific investigation. As science inquiry-based instruction becomes more prominent in the science classrooms, which include students with learning disabilities, research focusing on student learning is necessary to understand if science instruction is meeting students' needs. While many students have struggled with understanding science concepts, students with learning disabilities have even more difficulty with science content knowledge. According to the National Center for Education Statistics, more than 2/3 of students with disabilities receive science instruction in general education classrooms. Yet, students with disabilities demonstrate significantly lower science achievement compared to their same-age peers, who we already have noted struggle with the science curriculum. Through the process of inquiry, students engage in the practices of scientists by integrating skills and content knowledge into their scientific investigations. The Next Generation Science Standards address 8 dimensions of inquiry through learning for students K-12 education. Prior to beginning my study, I surveyed all science teachers in the school to determine the top 3 dimensions of inquiry that teachers focus on the most in their curriculum. Teachers noted that asking questions and defining problems, planning and carrying out investigations, and analyzing and interpreting data as the focus of their instruction. So you'll see these 3 pieces come up in my research questions. Although students with LD are frequently included in general education classrooms, how and if they truly access curriculum has yet to be determined. With the onset of the new standards in science education, how students acquire science knowledge is even more uncertain. Therefore, I conducted a cross-case analysis to understand how students with LD acquire science process knowledge through inquiry-based instruction while being provided known beneficial supports. Today, I'll focus just on research question 1, the acquisition of that science process knowledge. Participants for my study included 6 students, 3 male and 3 female, all with learning disabilities across 2 6th grade classrooms. Students qualified for a learning disability under the areas displayed by their name. Students were enrolled in inclusive science classes with 2 different science teachers, represented by the purple and the green, across 4 class periods. Each classroom had 1 general education teacher and 1 paraprofessional. In order to gain an understanding of students' science learning, each participant was considered a single case. Following a multiple case design, student similarities and differences were highlighted among individual cases and across cases. Data was collected through student portfolios, student and teacher interviews, and student observations. Data was analyzed using qualitative data analysis methods, including the coding for themes within and across cases. So to give you some background on what happened, the study was conducted at the start of the 6th grade year. So this was the students' first time in a lab setting. Ms. Vargas, one of the teachers, noted that change. She said, "We spent the past 2 or 3 weeks just talking about what is science and learning about what scientists do, since this is a lot of students' first time in a science lab classroom." At the beginning of the 9-week ecology unit, all 6th grade science classes attended a field trip at a forest preserve to conduct investigations. Students were placed in small groups with a teacher or a naturalist as their leader and spent the full day in the woods conducting an inquiry investigation. Students explored the forest and recorded at least 10 questions that came to their mind. Once questions were generated, groups discussed which questions were testable in one day at the forest preserve. Students then planned and carried out their own investigations, and then after collecting data, groups were required to display their data in graph form and share their findings with the class. Mrs. Rubin reflected on the experience. She said, "It really gave students a sense of how you find something out using good science." Ms. Vargas, the other teacher, also shared, "Students got to figure out what they wanted to study, how they wanted to study it, and then report on it. It was a really authentic science experience." So I'll show you what that ended up looking like in those 3 dimensions. According to the Next Generation Science Standards, asking questions and defining problems includes determining what questions have yet to be answered, identifying questions that are researchable, and distinguishing a scientific question from a non-scientific question. Here is an example of this process through Saley's work. On the top is a part of the list of questions that her group came up with when exploring the forest, and then you'll see one specific question was selected to investigate. Asking questions and defining problems was a challenge for students with learning disabilities. In the graph, red indicates students who were not able to identify the scientific question of their group, which was Mariah and Dion. For example, Mariah said, "I don't know which one." This is while she's looking at her pictures. This one, "Why is there bubbles in the water?" Santos and Virat in the yellow were able to identify their question when prompted. For example, Santos said, it is something that has to do with the bug thing. Like, are there more bugs in the grass line or in what area? I think that's what it is. Whereas Saley and Jonas in the green were able to identify their question independently. Saley said, are there more X leaves versus Y leaves on the ground? In the next dimension of inquiry, scientific investigations are conducted in a field or lab setting. Observations are conducted and data is collected, as a list of procedures are indicated. Here is an example of Virat's work. The procedure is pretty general, but it does provide a basic description of how the investigation was carried out and data collection is shown. Planning and carrying out investigation showed similar difficulty for students. Mariah, Dion, and Santos this time were in the red, and Mariah shared, well, we went to the forest and we looked to see. Virat was able to explain his investigation with prompting. He said, the bugs and spiders went under the logs. We marked this stuff. We had a flag, 4 flags, that we had a yard already, so this is an area we're experimenting on. We flipped over the log to find, we touched the bugs or animals with our bare hands. They were really excited to touch bugs. Saley and Jonas, again, were in the green. Jonas this time shared, we looked at both areas. There was a bunch of fallen logs, so we flagged that area out with our team marker and we looked for bugs. Our count for our logs were 19. Our count for the grass was 24. Data analysis can be seen in a variety of levels. Key components include identifying significant features and patterns in the data and sources of error identified. Here, Saley's group was able to create a graph. Here, let me show it to you, there we go. She was able to have a graph based on the data she collected. Her group acknowledged, we found mostly oak, though the kinds of oak varied. Analyzing and interpreting data showed more promise. This time, Virat and Santos were in the yellow and no one was in the red. Virat shared, when I asked him, what did the graph tell you? He said, it's telling us how much population is in the community of the forest is growing or not growing. I then asked him a little bit more, was there one place that it seemed to have more animals than the other? And he said, yeah, in the forest. 4 people this time, though, were in the green. Mariah, for example, who was in the red for the previous 2 dimensions, this time was in the green. And she shared, while she's pointing at her graph, she shared, these are the ones with the bark. Trees standing up with the bark, the trees down with the bark. Then these are the ones without the bark. Which has more? Trees standing. While I won't go into as much detail for this next lesson, I'll briefly share data so you can see the emerging pattern. Taken from Project Wild, Oh Deer simulates limiting factors for a deer population. This lesson was a full class simulation where the scientific question was provided by the teacher. Students then carried out the investigation and analyzed and interpreted the data. Similar to inquiry adventures, most students struggled with identifying a science question. While more students were able to describe the process taken during the investigation, students in the yellow were only able to describe some portions of the investigation or required prompting. However, when asked to analyze the data, most students were able to describe the pattern. Jonas, who is in gray for the first two pictures, was absent during the primary investigation. However, he was there when it came time to analyze the results. He shared, the data, we made it into graph of years, and by years I mean rounds. The number of deer for each year in each round goes up and down. It goes up, down, and then it goes back up. Why? For the number of resources that there are. The resources are getting lower and lower and higher round to round. Looking across the lessons, it was interesting to see that when students asked the scientific questions, like in Inquiry Adventures, they showed more understanding than when the scientific question was provided by the teacher, like in Oh Dear. Jonas also spoke about the benefits of concrete versus abstract lessons, sharing that unless he could go to California and touch the whales, he wasn't sure how some lessons could be more concrete given that he was in school. If you have a chance to check out the posters that are still up today, I encourage you to take a look for a follow-up to my presentation, which is a deeper dive into Jonas's case. As you notice, data showing Jonas is in the green throughout all of the graphs. However, lack of work completion and restrictive assessments made it difficult for Jonas to show his knowledge. Thus, Jonas's report card indicated that he earned an F in science, despite the knowledge he actually gained from the unit. Future research should address strategies, interventions, and tools to support students with LD in science and how peer interventions may be used to support students with LD during inquiry-based instruction. In practice, continued professional development is needed to address differentiation strategies in inclusive settings and how to effectively teach students with LD using inquiry-based instruction. Thank you.